5. We've got a function f of x equals x cubed plus 4x squared minus 3x plus 7, and we are asked to find the set of values of x for which f of x is increasing. Okay, so that's the important word, increasing. Basically what increasing means is we've got a positive gradient. If I'm talking about gradients with functions, straight away we should link that to differentiation. Okay, so if I know f of x, I want to find the differential, which is going to be f dash of x. Okay, so times by the power and take 1 off, we'll have 3x squared plus 8x minus 3. If I want it increasing, I want when that quadratic is going to be greater than 0. Okay, that I've got to solve, 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 that I've got to solve. Okay. How you do it is up to you. Remember, the first thing we've got to do is find critical value. Using a quadratic formula. That's fine, but you've got to show how you've done it. Do not lose silly marks. Okay, so I'm looking at multiplying to minus 9 with a difference of 8. So I'm going to want positive 9 and minus 1. So we'll go 3x squared plus 9x minus x minus 3 is greater than 0. So we'll have 3x lots of x plus 3 minus 1 lot of x plus 3 is greater than 0. So into factorised form, I'll have 3x minus 1, x plus 3 is greater than 0. So my critical values is a third and minus 3. Please do not now make the mistake of just sticking inequality signs next to those. Okay, you have got to sketch the graph, otherwise I can guarantee you will come unstuck in one of these questions somewhere and get it wrong. Okay, so I know my quadratic has roots at a third and has roots at minus 3. I also know it's got a y-intercept at minus 3. Okay, and I can sketch what it's going to look like. It's positive quadratic, so it's going to come down and come back up. Now I want where that quadratic is greater than 0, so I want those two parts. So I am now happy that I know x has got to be less than minus 3, or x has got to be greater than a third. Okay, remember we can write this in set notation if we had to, so we can do x such that x is less than minus 3, or x such that x is greater than a third. Doesn't ask us for set notation, so you don't actually need that bottom line, but it is worth remembering just in case that we need it. Okay.